Okay. I'm going to have, even though I'm not here today, I want to have you do this lab. And you should leave a page or two for, you don't have to write this down, but go ahead and leave a page or two for lab number 6, which was osmosis. Don't write this down here. Lab number 6 was osmosis. Leave a page or two in your notebook, although it doesn't really matter if they don't go in order. So that was the one that we did with the color dialysis tubing. And then, so we're going to call this one lab 7. And this is water potential of, let's just say, fruits and vegetables. And today is 10/14. And the question is going to be, is there a difference between you should write this as you go with me, between the water potential of a potato. So everybody's going to test the potato, and then you're going to pick another vegetable. So they're on the board, but I'm going to go ahead and write them down here on my notebook, but you don't write all the whole list down because you're only going to pick one of these. So there's 7, I think, that I have: celery, mango, zucchini. I can never spell zucchini. Pumpkin. What else is there? Sweet potato. Cucumber. And carrots. And I can only have one group per class. So we're going to have 3rd period and 4-5. So you have to pick only one group per class can do each of these. So somebody in 3rd period could do celery, and somebody in 4-5 can do celery, but not 2 people from 3rd period can do celery. So that's clear. So at this point, why don't you go ahead and talk it over with your lab partners and pick one of the vegetables. Don't fight over it. I think each of these vegetables are equally worthy of your research on them. So I just wanted to get a variety of different things here. And I've only have enough cut up for to do one per class of each of those. All right, so then you're going to do whatever your vegetable is, you're going to put here. All right, so of course we have to do our hypotheses. So our null hypothesis is going to be that there is no difference, or no significant difference, maybe you want to say, between the water potential of a potato and whatever your vegetable is you're going to put in that space. Okay, that's all the null hypothesis. And then our alternative hypothesis is going to be, I want you to make a hypothesis, a prediction based on which one you think has the lower water potential. And remember, lower water potential means you have more ability to bring in water. And so we're asking basically which one of these has the most solutes in them of the two, potato versus what you picked. Which one do you think has a more sugar, salt, solute in it? And that one will be the one that has a lower water potential when you calculate it. And so therefore, you want to predict which one and write a hypothesis. The water potential of whatever you think is going to be the case is lower than that of blank. So for example, if I think that an apple has more sugar and more solutes, so apple's not one of the things here, so I'll pick it. I'm going to say that the water potential of the apple is lower than that of the potato. But you're going to put whatever you have there. All right, so that is our hypotheses, our question, and our title. And we need to have methods and a data table for this. So let me go ahead and write out the methods first. I'm going to switch over to another piece here just because it's bleeding through and I don't want that to come up on the camera. So we're going to have materials and methods. This is where I'm going to explain to you what you're going to be doing. And I tried to find a handout, but I didn't find one that had just what I wanted to do for this particular lab in it. So we are going to write it out as we come up with it here. I'm going to show you what you're going to do in each of these steps during this part of the method. So I can show you what's going on here. Okay, so every class, the 2 classes that I have today, have a bin with the materials in it, like the vegetables that you're going to pick. So let me just say that, let's say third period is going to be the third period is going to be the green bin, and then 4-5, you guys are going to be the black bin. And the vegetables are all in little baggies. So hopefully you could tell them apart. You know, just be careful, like with zucchini, I should probably mark them, but zucchini versus celery. Zucchini, hopefully you know the difference, but never know. So that's a zucchini, and then this is the cucumber. I mean, hopefully, like I said, never know. All right, so what you're gonna do is you're gonna take each of your vegetables and you are going to cut out 6 cores from the vegetable. And to do that, you're going to use this thing called a cork borer, and I'll write this up in a minute. Maybe I'm going to do this first and then write it up. This is just my pen. You should have a little needle, and you could use the handle of the needle on your desk already in your bins. And you are going to use that cork borer to cut cores out of your vegetables. So the carrot is tiny. Maybe I should have gotten on baby carrots, but I gave you enough in there. And then you're going to use this to make a core, out of each. You need a total of 6 cores. And so you're going to poke it through there. Be careful because it is sharp. It's cutting the vegetable. And then you take your needle thing, your needle, not from the needle side, but the wooden side or the white side of it. And you're going to pop out your core. Oops. Sorry, MacBook. And that's it. So then you're going to do the same for your potato. And my suggestion is that you're going to match as close as you can. You don't need a ruler or anything, but to match the core from your potato as much as you can. So if you have a little vegetable here, you don't have to core through the middle. Some of these are already cored from yesterday. I thought I had more potatoes, but I don't, and I have to look for them because one year I lost a bag of potatoes and it was not pretty. Anyways, so you're gonna core the potato, and careful that you don't put your fingers like, oops, that you don't want to put your fingers while you want it to be away from your fingers. So, and then you're going to pull that core out, and it's okay if you get a little bit of potato juice on your notebook. That's a sign of a good scientist. I'm just kidding, but, and you push your core out. Now, what I'm going to suggest that you do is you take your scalpel and you cut off the skin off a vegetable if it has skin. And then what you're going to do is you are going to try as much as possible, make these to be around the same size. It doesn't have to be perfect. But like this one seems to be nicely, like if I just cut it in half, they're going to all be about the same size, and that's good. It's not critical because we're going to weigh these. So what you're going to do, that's the coring process. So let me go ahead and go back to the writing process, or what we're going to be doing here. So what you're going to do is you're going to use a cork borer. So a cork borer, your words don't have to be exactly like mine. A cork borer was used to make 6, that's what you want to cut, 6 of each vegetable, 6 uniform cores from whatever your 2 vegetables are, from a potato and whatever you have. Okay. The mass of each core was recorded. So because we're recording it, I don't think we need to say we take it. It's obviously we're going to record it. We're going to take it and record it on table 1. Each core was then placed in a cup and covered with enough volume just my wording got messed up here, but you get the idea, with just enough to cover, with enough volume just to cover the cores. I should probably tell you and have you measure out a specific volume, but that's not critical here. So I left that out. And okay. Of each of the following sucrose solutions. And those solutions are going to be 0 molar, 0.2 molar. Each core is going to go into its own molar solution, and you're going to put both cores in the solution. So I'll show you in a minute here. And you could probably see on the desk from yesterday, but don't disturb theirs. 0.4 molar, 0.6 molar, and 1 molar solutions of sucrose. And those will be up front in big 1 liter Erlenmeyer flasks. And just use enough to cover it, because otherwise I don't want to run out, but I think we should be okay. So the amount is not critical, but just enough to cover it. And make sure you label each cup with that volume. So I think I'm going to go ahead and set up my own experiment. just not, I'm gonna record the whole thing, but you have the cups. It doesn't matter what cups you use. You could use the same cups from your other experiment. I'll have cups on the cart too. And just make sure you have the molarity written on it and your initials and maybe whatever class period you are. So I'm gonna label this one 0 molar kg and then third period or something like that is fine. And then I'm going to do that for all the rest of my molars here. All right. So I have 2 molars set up here already, or 2 different solutions. I have my cores, so I'm going to go ahead and put my cores in here. So picture is worth 1,000 words. Let me get another core of my carrot. Careful not to use that by your fingers. And then you just use your needle, the non-sharp end of your needle. And now I have my other 2 cores. And then I'm going to go ahead and just go get my solutions real quick. Sorry for not, I should pause, but it doesn't let me do anything then. Oops. Solutions already in the back of the room. 0 molar, 0.2 molar. Oh, see, I already forgot. Good thing I didn't pour the sucrose yet, although it wouldn't have been enough to really matter. But I got to take my masses of them. So you guys know where the scales are. They're in the orange cart. I have a couple new scales that I just picked up from Amazon. So if you want to use one of those, put the scales back when you're done as well. You have, I think most of the things are, cords are in the outlets. That's fine to keep them on outlets. All right, so I should make sure that's on a flat surface. And I am going to turn my scale on here. You should use a weigh boat. So I'm going to do that. That's why I don't ever clean off my desk, because everything is right here. No, I'm kidding. I really need to clean off my desk. All right, tear out your weight of your boat and then get your core and then write that in the table that I'm going to show you in a minute here. So I'm going to write the table and then do your other core and write those in the table. And then you're going to pour your sucrose on there. So this is my 0.2 molars. So I'm going to take my flask. Got my flask here. I'm going to take that and put it just enough to cover. Let me see here. Yeah, I think that's good. Maybe a little bit. I don't need that much more because I need that to last whatever's there. I need that to last, you know, a good 10 groups or so. So just enough to cover is fine. That's probably a little too much, but it's not gonna mess the experiment up. I'm just trying to get this to not run out. I'm gonna probably fill these up a little bit just to make sure that there's enough. Okay, so let's go back to the table. And hopefully this is not confusing. All right, so I'm gonna make table 1. And what we need to record is the initial weight. I'm really bad at making tables on the fly. Initial mass. And then this is going to be a 24-hour experiment. This is a 24-hour mass. And then we want to calculate the percent change. All right. And we need to have and we need to have our potato and then each molar. So I'm going to go ahead and write like my potato masses here. And it doesn't matter that you write the table this way. Like I said, I'm not that good at making these tables up on the fly. Yours is obviously not Apple. And then I need to have have 0 molar, 0.2 molar, 0.4 molar, 0.6 molar, 0.8 molar, and 1 molar. Okay, that works. Maybe I left too much space here, but same thing for my my apple, 0 molar, 0.2 molar, 0.4 molar, 0.6 molar, 1 molar. All right, so that's your, oops, this should go, this should go here, sorry. And then my initial mass is not, this is a concentration. So, I don't know if I can edit this video because I'm just doing this in Zoom and I don't have my other computer. So just make sure that you have, this is going to be your concentration. And then this is going to be your initial mass. Okay. 24-hour mass, something like that. Somewhere to write data down that you can interpret it later of what it is. And that's it. So you're just going to put them into one of the bins on the desk neatly. Throw away any vegetables that you have. And the potato, if your potato is pretty wholly, maybe toss it. And if it looks like it still has some good cores that it can be taken out of it, then put it back in the bin. And I think that's pretty much it for today. And then we will, I'll show you how to calculate the water potential probably on Monday. We will, on Friday, we have our test and we'll just get the weights super quick. When somebody's finished with their test, they can just take their masses really quick. And then we'll finish it up on Monday. So apologize I couldn't be here and I'm giving you, it's not a very complicated lab. So I think that you guys will be fine with it. All right, have a good day, guys. I will see you tomorrow. Email me if you have any questions. I will be available by email.